Alrighty folks, this is our last video for chapter 8, and I've realized I've been a terrible YouTube personality because I don't ask you guys to like and subscribe and click the notification button in every video, and I also am not opening surprise bags or eggs, which I feel like is necessary to be a good YouTube personality. So please like and subscribe, and at the end of this video we'll open up some Star Wars Microforce figures so you can call your children or younger siblings into the room. For the end of this one, we'll have a little bit of fun and end this chapter on a light note. Alright, so let's get to our last example, an unknown substance example. So one of the ways we can use the knowledge from this chapter is to determine unknown substances. One way of doing that is heating them up, putting them in water, and observing how the temperature changes. The way in which heat is transferred from your object or your substance to the water helps you determine what that substance is. So, in this example, we have 250 grams of an unknown substance at 100 degrees Celsius. It is placed in 500 grams of water at 22 degrees Celsius, and we're told if the equilibrium temperature is 29.7 degrees Celsius, what is the specific heat of the unknown? And then once we know that, we can use that to determine what is the substance. So, quickly in words, what's going on in this problem? Well, we've got an unknown substance that is hot, 100 degrees Celsius. We brought water up to a boil and put this substance in the boiling water. And then we've got room temperature water at 22 degrees Celsius. The hot unknown substance is going to cool down. All of the heat that it releases is going to the room temperature water, which is going to heat up. So we have the substance cooling down, the substance cools down, the water heats up. And we know that all of this should result in a net change of 0. Any heat lost by the substance is gained by the water. We really have the sum of Q, which is Q1 plus Q2, should equal 0. And both of these are a change in temperature. The substance temperature is changing, it's going down. The water's temperature is changing, it's going up. But both of these Q's, these amounts of heat energy, can be computed with Q equals mc delta T. Both of these are a change in heat energy. We'll call this M1C1 delta T1, call this one M2C2 delta T2. And what are our values for those? Well, let's call the substance M1. We have 250 grams of it. C1 is actually our unknown. We're trying to figure out the properties of this substance, how much heat it takes to change its temperature. Well, what is the change in temperature then? Well, we know initially, T1 initial is 100 degrees Celsius. And then it's going to end at the final temperature, the equilibrium temperature that everything ends up at, of 29.7 degrees Celsius. Now, for the water, that's M2, we have 500 grams of it, 500 grams of water. The specific heat for water is 1 calorie per gram degree Celsius. The water's initial temperature is 22 degrees Celsius, and the water ends at that final equilibrium temperature, the same as the substance, 29.7 degrees Celsius. All right, well, let's put all of this together. We know that everything lost by the substance is gained by the water. We should expect this term to be negative because the temperature goes down. We should expect this term to be positive because the temperature goes up. All right, well, plugging things in, we have 250 grams times the unknown C1 times delta T1, which is T final, 29.7 degrees Celsius minus T initial, 100 degrees Celsius. And we can see right there, 29.7 minus 100 gives us negative 70.3 degrees Celsius. That is the total amount of change. It decreases, so we have lost heat. This piece is negative. Then we add M2, which is 500 grams, times C2, 1 calorie per gram degree Celsius, times delta T2, which the final temperature is 29.7 degrees Celsius, minus 22 degrees Celsius. That's a total change of a positive 7.7 degrees Celsius. So this term is indeed positive, and all of this should add up to 0. All right, well, we can multiply 250 grams times negative 70.3 degrees Celsius. That gives us negative 17,575 grams times degrees Celsius. And all of that is multiplied by C1. Then we add 500 grams times 1 calorie per gram degree Celsius times 7.7 degrees Celsius. The grams cancel, the degrees Celsius cancel, and when we multiply everything together and the dust clears, we get 3,850 calories. We are left with calories there. All right, we're almost finished solving for that C1. Let's subtract 3,850 calories from both sides. So we have negative 17,575 gram degrees Celsius, all times C1 equals negative 3,850 calories. And lastly, we can divide by negative 17,575 gram degrees Celsius. We do it to both sides. And we can see our units that we end up with are calories per gram degree Celsius. That is indeed what the units of specific heat should be. And what is negative 3,850 divided by 17,575? Well, that gives us 0.22. And as I said, the units are calories per gram degree Celsius. So that answers the first question. What is the specific heat of the unknown? Well, C1, that unknown specific heat, is 0.22 calories per gram degree Celsius. And then to answer what is the substance, well, we're going to have to take this specific heat that we computed and look it up. So those of you with the practical physics book, there should be a table on page 162. I'll double check where the table is in the alternative text from OpenStax, or you can just Google a list of specific heats. But I'll go ahead and ask you guys to comment below what you found that substance to be. This is right on the nose for a common substance. So go ahead and look that up and answer the second question. I'll let you guys do that on your own and figure out what is this substance. And you could do this if something fell from the sky, a meteorite, if you wanted to go try to determine what it's composed of. You could perform this experiment, and you guys will be performing a similar experiment, heating up some pennies, I believe, and determining what they are made of in our at-home lab for this. All right, well, I'm not gonna disappoint. I did promise you guys we would open some Star Wars Microforce minis at the end of this video. So now is the time to call in your children, your little brothers and sisters, or whoever, if you're babysitting. Let's find out what sort of fun little figurines we're gonna get today. There's our list. We could get Stormtrooper, Darth Vader, Han Solo, Boba Fett, Luke Skywalker, and Chewbacca. Or Wicket, Yoda, Princess Leia, R2-D2, Ahsoka, or C-3PO. There's going to be two little guys down in here. Looks like Darth Vader and Princess Leia. I think we actually don't have a Darth Vader, so my son will be excited for that. I think we've got a couple of Princess Leias floating around. At least one I'm pretty sure I've seen before. But that's a good little combination. Darth Vader can say some intimidating things to Leia about rebel scum and secret plans for the Death Star. But anyway, thanks for tuning in, guys. And like I said, make sure to like and subscribe. Trying to get that YouTube money. Anyway, hopefully this has been helpful and informative. And if you guys have any questions, as usual, send me an email and I'll be quick to get back to you.